Welcome to the third video of this series about object-oriented programming and classes in Python. In this video, you're going to learn how to use special methods, also called dunder or magic methods, to implement different behaviors when, for example, you add two numbers together, you print an object, etc., etc. So, here I've got the class we used also in the previous videos with just the init method, okay? The init method is actually part of the special methods, and they are special methods invoked using a specific syntax. We've already discussed init in a previous video, so I'm not going to talk about it specifically. So, a special method is used to describe what to do when using a special syntax, but what is the special syntax? Well, let's see an example. So when you add two numbers together or two strings together, Python recognizes the plus sign and uses one of the special methods under the hood. So let's actually write two strings, so string 1 and string 2, okay, something like that. And then we print string 1 plus string 2. And of course we get something like A, B. So here Python sees that you're trying to add two strings together using the plus sign here. And because you have two string objects and the plus sign, when you do this, Python actually uses the __add _ special method of the string class, of course. So basically, when you use the plus sign to add two strings together, Python does something like this. So string 1, add, like that, and then string 2. And if you actually print it and run it, you can see that AB, they return the same result, okay? So this is just an example, but Python does this when you use the minus sign, the len function to get the length, when you print something, when you compare objects using the is greater than, is equal, etc., etc. So having these methods available means that we can actually create our operation for our classes, which is incredibly useful in my opinion. So let's actually delete the example here, okay? And see what we can do with our class. By the way, there are a lot of special methods you can use, so it would be impossible to go through all of them here. So I'm going over the ones that I think are more useful and you're more likely to need, but you know that in the docs you can find all of them. I'll leave all the important links in the description box down below. So let's say we have two instances, so person 1 and John 54 London, and then we've got person 2, let's call it David 24 and Austin, something like that. So if we print them, we get something like this. So if we print the instances directly like this, print like that, we get something like this. So we get main, person, object, etc., etc. So as you can see, we just get that this is a person object and this is the address basically. So you need to know that when you print something, Python looks for the special method str, and in case it doesn't find it, it uses a method called repr. Let's actually add them to a class. So let's say that we want to add repr like that. We need to pass self as usual like that. Okay, so this method, as stated in the docs, should be a representation of the object that we can actually use to create the same exact object if we were to use it. So in this case, something like this. So we want to return an f string. I'm going to use double quotes. So person, self.name, then self.age, and then, of course, self.city, like this. And let's close that. Okay, so the repr method is called when you use the repr built-in function and when we print an object and we haven't specified the str method. So let's try to actually print that. Let's do something like this. So print repr person 1, and this is actually the same as doing something like print person 1 dot repr like that. Okay, so this is the same thing. And if we call that, as you can see, person John. So this is that. And as you can see, this is the representation of what we actually use to create an object. So this is the same as this. Okay, so if you just copy and paste this, you can create that object. And if we print without using the repr, so person 1, something like that, you still get the same thing because the special method repr is sort of a fallback if you don't specify the str method. So let's actually write that here. So def str self. Okay, basically the str method is the one used when you basically print an object of this class, or when you use the str function to convert the object to a string. So in this case, I want to return an f string, and I want just to add the name and then the age like this from, I don't know, self city. Okay, I'm just making this up like that. So now if we run this again, so this thing again, we get, like, as you can see, John 54 from London. As you can see now, using the, when we print that, we get this, the str, the result of str, and if we use that thing with repr, you get this. Okay, cool. So as I mentioned, this is also used to convert the object to a string. So for example, if I wanted to do something like person string str person2, and then I can print type person string, so that you see that you get a string and then person string like that. As you can see, you get class string David from Austin. So by using the str, you can convert the person1 object to a string, and this uses the str method like that. Okay, so the result is actually what you get. Perfect. So now let's say that, let's actually delete this. Okay, so now let's say that we want to compare two person objects with greater than, less than, etc., and we want to compare them based on their age. How can we do that? So to do this, there are other special methods. So let me copy a sort of table here. Okay, so lt less than or equal, equal, not equal, greater than or equal to something. And you can find those in the documentation as well, so I'm gonna delete them from here. So let's actually try to implement them. So let's try to implement the less than. Okay, so you've got self and other. So what is other? So basically, self is the instance on the left of the sign, and other is the one on the right. Because when you do something like, let's say 5 less than 10, Python calls this method on this object, on the 5 integer object, and the other here is 10. Perfect. So we need to return, of course, self.age less than other age. So you get true if the age on the left is actually less than the age on the right. In this case, person 1 is 54 and person 2 is 24. So if we do something like print person 1, person 2, I'm just printing them, but you can use something like if person 1 less than person 2, etc. And also this is the same as doing something like person 1 dot lt person 2. And if you were to have person 2 here and person 1 here, this would be inverted as well. So if we run that, false and false. So basically Python sees the less than sign here, okay, and uses the right method, and it does this for all the other symbols like the greater than, etc., etc. And even though we haven't written the GT method, which stands for greater than, if we do something like print person 1 greater than person 2, and we run that, we get true, and it still works because we have written the LT function, and Python automatically sort of creates the GT function because it just has to invert the result. Of course, if you want to have the GT function that works differently, you can specify another logic, okay, by defining the underscore GT underscore and write something else in the body of the method. Of course, the less than or equal to and the greater than or equal to are different signs, so you need to specify the LE and the GE methods. Otherwise, you would get an error about the fact that it's not implemented. I actually just want to mention one thing about the equality. If you don't specify anything, Python is going to use the is keyword to compare the two instances. I actually talked about the IDs and the is keyword in another video about mutable and immutable objects. So let's say that we have these two instances. So let's delete those. So let's actually delete this and duplicate it like that. Okay, so they are equal, but they are not actually the same object in memory, which means that if we do something like print person 1 is equal to person 2, and we print that, you get false because they are not the same object, although they have the same attributes, etc., etc. And we can change this behavior by using the EQ method. So def EQ self and other again. So we can do something like return self.name is equal to other.name and self.age is equal to other.age and self.city is equal to other.city. So an object doesn't need to be the same object in memory to be equal to another one. It just needs to have the same values. So now if we save that and you run this, you get true because all of these here are the same as these. Even though these two objects are not the same, they are equal because they have the same attributes. So now listen up, because I'm going to explain you one important thing. So if you don't set the EQ method, the object can be used as, for example, dictionary key because it's hashable, okay, by default, and it uses the ID to calculate the hash. But if you set the EQ method, as we did here, then the object becomes unhashable. So to check if an object is hashable, we can use the hash function like this. So we can do something like print hash and then person1. If we try to run that, you get type error unhashable. But if we didn't have the EQ method here, you get this. As you can see, you get a number, which means that the actual object is hashable. Okay, let's go back here. Perfect. So you've got the EQ method, and you can also have the hash method, but the hash method shouldn't be defined if you don't define the EQ method. And actually, really important, most of the time you don't want the object to be used as dictionary key, especially if your class defines mutable objects, like in this case. So if you define the EQ method and you don't define the hash method, automatically the object won't be usable in hashed collections like dictionaries, because this is unhashable because we actually added the EQ method. But if you don't need to define the EQ method, so let's say that you don't need this, so you didn't write it, or maybe the hash method is inherited from a parent class, for example, the object would be hashable and that wouldn't be good, okay? So to flag it as unhashable, you can set this in the class definition. So you can set something like up here, like hash none. So now the object should be hashable because we didn't define the EQ method, but still you get unhashable because we added this one. If we were to remove that, as you can see, you get something. Okay, so this is actually working. And if you want the object to be hashable, maybe because you want to use it as dictionary key, which in this case doesn't make sense because you've got a mutable object, so you shouldn't do that. But let's say that you want, we can actually uncomment this, okay? You can actually use the hash method, but you need to keep in mind that objects that compare equal using this, the EQ method, need to have the same hash. So let's actually define hash self. So in this case, we are creating the hash method, and usually it's good to put all the attributes used in the EQ method. So here, set name, age, and city into a tuple. So put them into a tuple and then hash that tuple. So in this way, you show that the objects that result equal to the EQ method also have the same hash. So in this case, you want to do something like return hash, and then tuple in here, self.name, self.age, self.city, like that. So you hash this tuple, and inside of here, you've got all the attributes here. As you can see, set name, age, city. By doing this, you're saying to Python that the object person is hashable and that it can be used as dictionary key, for example. But remember that this is not what you should do in this case, okay? Because you've got mutable objects. By the way, just a side note, the hash returned by the hash method is different between Python invocations. So as you can see, now you've got hash person1, okay? You run it, you get this number, you run it again, you get this number, so they are not the same. And this is done for security purposes. So if you need a hash that is consistent between Python invocations, maybe because you want to store it in a database or something like that, you should use a module like hashlib, for example. Then, Before we look at how to implement arithmetic operations like adding two instances together, subtracting, etc., let's quickly have a look at the special method bool, which is basically a way to see if an object is true or false. So to do that, we need to add this method here, this special method, which is bool, of course, and then self. And then here, let's say that the person object is true if we have a name, an age, a city, and if we don't have a name or a city or whatever, the object is actually false. So if self name and self age and self city, return true, else return false, like that. Okay, so let's say that we want to see if the person one is true or false. We use the bool built-in function, person one, person two. Okay, and let's say that here we don't have the name. If you run that, you get false and true. Of course, if you had the name, you would get true and true. And this could be used like, for example, something like if person one print true. Again, you would get true, true, and true. Perfect. Let's now talk about arithmetic operations, and they are quite useful and worth learning. By the way, if you want to help me a little bit, please like the video and subscribe to the channel. It's really simple, yet really important for me. And also, if you want to leave a comment down below, I always appreciate them. So there are a lot of operations like addition, subtraction, multiplication, division, etc. We're just going to have a look at a few because otherwise the video would be too long. I'll leave all the useful links in the description down below if you need them. So let's see what happens if we add two person instances together. So let's actually delete this. Okay, so print person one plus person two, like that. And let's see what we get. We actually get unsupported operand type plus because we didn't specify that. So to implement the method, we need to add the add method here. So def add, then that takes self and also other, where self is the object before the plus sign and the other is the one after the plus sign. So in this case, person one is self, person two is other. And let's say that we want to return the sum of their ages. Okay, it doesn't make sense, but you'll definitely make things that make more sense. So return self.age plus other.age. So now if you run that, we get 48. Perfect. In this case, you could even return a new person object where maybe the name is the two names together, the age could be the sum, etc. So let's actually try that. So let's say name is equal to an f string with self.name and then other name, like that. And maybe the age is not actually, so you've got age plus other.age, like that. And then the city would be city and other city. Then we can return a new instance. So person, name, age, city, like that. So now if you run this, you'll see that you'll get a new instance. So as you can see, David, 48 from Austin. Let's actually change it and write something different. So like that, something like that. Okay. So you get something like John David, 58 from London, Austin, something like that. And we can assign it to a new variable because we're actually returning a new instance. So we can do something like new person, person one plus person two. And then we can use that. And let's actually use the IDs to see. So person two and then new person, like that. And let's see what we actually get. As you can see, all of them are different because we've actually created a completely new person object by combining the other two together. And it doesn't make a lot of sense, but it's just an example. And this is actually used also when we do something like this. So let's actually delete those. This add here is used also when we do something like person plus equal person two, which is equivalent to, of course, you know that this is the same as doing something like plus person 2, like this. And in this case, it doesn't make sense because basically you would end up with a completely new object in person 1. So you've got person 1 and person 2. You add the two things together, and then person 1 becomes a new object because you're still using this with a new, and you return the new object. So you get a new object in person 1. So if you do something like print ID person 1, and then you comment this out and you keep this, okay, and then you duplicate this, move that down here. If you run that, you can see that you get two different objects. So basically, you've got a person 1, you've got a person 2, you add them together, you create a new person object, and you assign it to the person 1. But it doesn't make sense because in this case, you can just update person 1, right? So to actually change the behavior of the plus equal sign, you can use a new special method, and there is one for all the operations. You just need to add an I before the name. So you can do something like def I add self other, and instead of returning a completely new object, we can just update the person 1 because we're basically adding person 2 to person 1. I know that it doesn't make sense. I keep saying this because you might be thinking, what the hell is it doing? But of course, your object is going to make more sense. This is just an example. So self name is equal to F. Let's actually copy those from here. So self name like that. Okay, like this. Of course, you need to do something like self.name, self.age, because we are updating basically the self, which is the instance on the left of the sign. And here we can just do something like plus equal other age, like that, self city, other city, name, etc., etc. And then we return self because we don't want to create a new instance. We just want to update the instance on the left. So in this case, the ID should be the same. As you can see, this is exactly the same because we didn't actually create a new object. We added person 2 and we added that to person 1, and we just updated the person 1. We didn't create a new instance. Okay, perfect. So in the next video, we are going to talk about subclasses, inheritance, really interesting. So if the video is already out, you should see it on the screen along with the playlist containing all the videos of this series. And don't forget to like this one if you enjoyed it, and also subscribe to the channel for more videos like this, and I'll see you soon. Bye.